Hello, Mr. Eric, Mr. Ryan, are you right? Yeah. Remember what we have talked about this quadratic equation. Yeah, quadratic. What's quadratic? Quadratic equation. What's quadratic mean?
It's this
What? What's called? You said it's 4, right?
Four,
But
yeah.
it's not 4. Quadratic. So ax.
Oh, is this a symmetric thing?
Yeah. Ax squared plus bx plus c equals 0. Right? This is quadratic because we only have one unknown, which is x. Okay, unknown. This is x is unknown. We want to solve it. A, B, C are constant, where A is not equal to 0. If A is equal to 0, then this whole thing is gone. It's bx plus c. It's not quadratic. Okay, make sense?
But bx plus c
Equals 0. That's
that
a
means
line.
it's nothing.
That's a line. Okay. If you draw this, remember parabola. Yeah, parabola. Yeah. The graph it looks like, yeah, these are, yeah, 抛物线. Yeah. Going up or going down. If A is positive, it's going up. A is negative, going down. Okay. Okay, so
You can do it by
yeah, that's fine. Okay, so now we talk. Today we're going to solve this problem. We're going to find the roots. The roots. Okay, what are roots to this equation? Right? Given it's A, B, C, if there are any, right? Sometimes they don't. We don't have any. Sometimes this quadratic equation does not have any roots, right? Or it could have a, imaginary root, which is not real. Okay. So these roots. So first of all, look, Eric. So first of all, can you tell me A times B plus C? Can we write it as what? What does it equal? The addition rule. Remember? A times B plus A times C, right? Does it make sense? Yeah? Yeah? This is simple, right? Like I'll give you an example. 10 times 20 plus 5, what does it equal? Come on, give me an answer.
1,000.
Huh? 10 times 20 plus 5.
I mean, 250.
250, yeah? So what does it equal? It equals 10 times 20 plus, you see 10 times 20 plus 10 times 5, right? This is 200 and this is 50. And if it's negative, it's the same, right? If it's minus, you can change it to minus, right? Got it? This is called addition rule, right? Okay, so we know this, and how about this? A plus B times C plus D. So how can we write this? Okay? So the exchange rule will be something like, look, you can take this whole thing as one term. Okay? Yeah. Take this whole thing as one term, right? So it will be A plus B times C plus what? A plus B times D, right? Yeah, this whole thing is a term, right? Ryan, you're looking at, right? Yeah. Okay, and now if we keep expanding this, right, like this, it will be AC plus BC plus AD, yeah? AD plus BD, right? Yeah? Okay? And then look, if we look, this is tough. If we can join this, right? You're going to join this, that will be A C plus D plus what? B C plus D. We join these two terms, right? Okay, and then look, this is common terms, right? C plus D, and then times A plus B. Okay, it's the same, yeah? So the point I'm doing here is I want to prove that this additional rule, right? So you can take this. So how, look, if it's the same, A plus B square, right? So it's actually what? A plus B. If A plus B times A plus B, yeah? A plus B times A plus B. So it's actually A plus B squared. What does it equal? Right? We can do this whole thing. Take this. So A plus B times A, right? Yeah? And plus what? A plus B times what? Times B, right? And this thing you know, right? It's A squared plus AB plus AB plus b squared. Okay, so what do we have? A squared plus 2 times ab plus b squared. Okay, so this is very important. Okay, a plus b squared equals a squared plus b squared plus 2 times ab. Okay, yeah, make sense? Okay, Ryan, are you alright? A squared plus b squared plus 2ab. Okay. Now we have known this. Okay, so let's do this. Look, a squared plus bx plus c equals 0. And how about if I move the c to the right hand side? So what does it equal? If I move the plus term on the other side of the equation, we need to do what? We need to change the sign, right? Eric, am I right?
Yeah.
So what does it equal? So ax squared plus bx equals minus c. Okay? Yeah? Yeah, we simply move the constant to the right hand side. And we need to give it a negative to negate the number. Okay, and how about if I times 4a? Yeah, 4a to the both sides. Yeah, because they are the same. So if I multiply both sides, 4 times a. Okay, so what does it equal? 4a squared x squared plus 4abx equals minus 4ac, right? Yeah? From here to here, we multiply both sides for a. Right? A is not equal to 0, right? We know that. And now, next step is, okay, then we do this 4 times 4a. And then here I want to add a b squared to both sides, right? If both terms are equal, if the values, expressions, on both sides of the equation, we can add the similar terms, the same thing, right? So we add the b squared. So it's 4a squared x squared plus 4ab x plus b squared equals what? B squared plus 4ac, right? Got it? Okay, so this is the magic. So this left hand side equals what? Equals 2ax plus b squared. Yeah? You see? Hey, look, we have talked about this. A plus b squared equals what? A squared plus 2ab plus b squared. Right? Yeah? Yeah, we know that. Yeah, I just showed you before, right? And so we can check if this equals this. Yeah? This thing square is 4a squared x squared. This thing square is b squared. Yeah, so we have these two terms here. And 2 times ab. So if we times this times 2 is 2axb times 2 is 4axbx, right? 4abx. Yeah, exactly. So look. Yeah? So look at 2ax plus b squared equals b squared minus 4ac. Okay, if we square root of both sides, yeah, if we square root of both sides, right? So we need to put a plus minus because it has two roots, right? So look, x squared equals 16. What's x?
4.
4, and another root is minus 4. Remember? Yeah. 4 square is 16. Minus 4 square is also 16. Because minus 1 times minus 1. Double negative makes positive, right? So that's another rule. So if we square root of this, so 2ax plus b, square root of this, b squared minus 4ac. And we need to put the plus minus sign. Yeah, right? That's what it means. And now, this is easy. We want to find the value of x. We need to find. By the way, you don't need to remember all of this. I'm just showing you how we get the final equation, right? Yeah. Okay. Now look. So 2ax plus b equals that. Then x equals what? X equals minus 2a, right? Minus 2a. No, 2a. If you actually, let's do it one by one. Okay, so it doesn't get confused. Minus b to the other side. So b squared minus 4ac plus equal, and then minus plus equal minus b divided by 2a. Okay. Okay. So this x is equal this. 2a minus b plus minus square b square root of b squared minus 4ac. Okay. This is the final equation. It's not easy, yeah. It's not easy to remember, but that's okay. You can always look it up, yeah. If we have an equation like, look, Eric, 2x squared plus maybe let me write x squared plus 2x plus 1 equals 0. Okay, so what's x? What's the value of a in this case? What's ABC? A is what? What's the term before the
1.
1? Right now. What's the b? Coefficient. B. What's the term before the 1? Linear.
0.
Why is 0? What's the value before x? What's the value before x?
2.
2. What's the value of c? What's the constant term? Well, which one? Constant term.
1.
Yeah. Okay. So what's the rule of it? X equals that. So x equals what? 2 times a, 2 times 1, minus b is minus 2, plus minus b squared 4 minus 4 times a, which 1. Yeah. Okay. So what's this number? 4 minus 4, 0. Square root of 0, 0. 2 minus 2 divided by 2, minus 1, right? So the root is minus 1. There is only one root. Why is that? Because plus, minus. There are actually two roots, but they are still the same. So it's both minus 1. Okay, let's put it back. Minus 1 square plus 2 times minus 1 plus 1. Is it equal to 0? Minus 1 square.
1.
2 times minus 1. 2 times minus 1.
Minus 2.
Plus 1. What's this?
0.
Yeah. You see? We find the root. Is it? Yeah? Okay, so why is that? Look, why is that? Because look, this x, it can be written as x minus 1 square. X plus 1 square equals 0, right? Yeah, remember, we know a plus b square equals a square plus 2ab plus b square, right? Yeah, we already know that. This is very important, yeah? Now look, let's verify if this is x square plus a square plus b square plus 2 times of these times together. Yeah, you see? So look, x plus 1 square equals 0. What's the value of x? What's the value of x? X plus 1 square equals 0. What's the value of x? If you get the square root, so what's this? This is 0. So what's x?
0.
X plus 1 equals 0. Minus 1. Yeah, you see?
Yeah.
Okay. Okay, another example. Okay. X minus 3 times x plus 4 equals 0. What's the possible value of x? Come on, this is easy. X minus 3 times x plus 4 equals 0. If two numbers multiply to 0, what does it mean?
They're 0.
One of them is 0, right?
Yeah.
So either this is 0 or this is 0, right? So if x is 3, this is 0. If x equals minus 4, this is 0. So there are two roots. Yeah, there are two roots. And look, this is two roots. This is easy. But if we convert it to the standard ax squared plus bx plus c equals 0. Look, what's this? X squared plus 4x minus 3x minus 12 equals 0. So right? X squared plus x minus 12 equals 0. Okay, so look, this is A. A is 1. B is 1. C is minus 12, right?
Yes.
Yeah? Okay, so if let's verify that to see if it's correct, okay? Let's just double check. X squared plus 4x minus 3x minus 12, yeah? So look, 2 times A, 2, minus B, plus minus B squared plus 4 times 12, so 48. Yeah? 48 plus 1, 49. What's the square root of 49?
7.
Yeah, so 7. This whole thing is 7. So there are two roots. Minus 1 plus 7 divided by 2, or minus 1 minus 7 divided by 2. When it's plus, that's 3. When it's minus 4, right? Yeah? You see? Yeah, you see? It's the same. Yeah, you see? It's the same. Okay? Okay, so why is this useful? Okay, why is this useful? Okay, so sometimes it doesn't have a root, right? For example, look, if you plot this in the graph x and y, right? If the graph is like that, there's two roots. Yeah, when y is 0, there are two roots, right? Yeah, two roots. Yeah, am I right? But if a graph is like that, does it have a root?
Nope.
It doesn't have any connection back to the axis, right? And how about this? Does it have a root? Yeah, it have two roots. Yeah, two roots. Okay. So when it doesn't, look, because we have a term b squared minus 4ac. If it only has roots. Okay, we call it roots, real roots. If and only if b squared minus 4ac is bigger or equal than 0, right? Can you tell me what's the minus negative 16 square root, right? There's no real roots to get it, right? Yeah? Yeah? But we have, look, these things, square root, the real root for the square root, right? It needs this term inside the square root be bigger or equal than 0, right? That's what it means. So when this thing, b squared minus 4ac, is bigger or equal than 0, then this parabar, yeah? Parabar has the what? Intersects with the x-axis. We can find the roots, right? Either 1 or 2. Two roots, yeah? Okay? Am I right? Look, y equals x squared. Yeah. The root is here, connection 0. Yeah?
Yup.
X squared plus 1 equals 0. What's x squared plus 1 equals 0? It's here. It doesn't have connection with the x-axis, right? So it doesn't have any root. But how about...
It has, oh no, it doesn't.
It doesn't, right? Because it's facing that. How about this one? What's this? It's minus x squared plus 1. Is it? When x is 0, y is 1. 1, right? So look, it has two roots, right? It has two roots, right? Okay? Because when A is negative, this whole thing is facing down, right? This whole thing is facing down. So when x is 0, it's 1. So this is facing down, right? So you have two roots, right? Okay, so now today, easy. Given the final thing before I forget. Given this ax squared plus bx plus c equals 0, okay? And we want to find the real root. So find real root, okay? Let's say real root because it has other roots, but we are focusing on the real roots. A, B, C, okay? Given 3 numbers, right? So look, if A is 0, okay? If A is 0, we want to raise exception, okay? We can say raise value exception or exception. What's exception mean? A is 0.
You can do stuff.
Exception means that okay, there's some errors. It's quite similar to assert, yeah. Assert, yeah. Assert.
Then why don't you write
assert? Yeah. Assert is what's assert? It's
To
computed
check.
to double check, yeah. If A is 0, then I can't continue, right? Because it's not what I designed this algorithm for, right? So let's write it A is 0. If A equals 0, then we return. We raise an exception and return, okay, whatever. If B square, B times B square minus 4 times A times C, right? If it's smaller than 0, what does it mean? We don't have a root, yeah? The graph doesn't have a connection with the x-axis, right? So we can say raise exception, okay? Doesn't have a root, doesn't have a root, right?
Well, what's that line for?
Yeah, I'm just lazy. Yeah. Raise exception. We don't have any real root, okay? And then now we want to return two roots, yeah? So we can save this term. So what's this term? Let's call it what? R equals B square. Yeah, B square. This is B square. B square, you can write it B times 2, okay? Or B times B, okay? Or power B2, yeah? These three things, same. These three are the same, yeah? Yeah, these three are the same. They are all B square, okay? You can write it in Python using this approach. Minus 4 times A times C, okay? And then we know, at this point, we know this thing is bigger or equal than 0. So we want to get the square root of it. So we can do this SQRT, math SQRT, yeah? Square root. Yeah, how do we do the square root? Square root B, we can also use this square root SQRT, this function B. Or we can do this B times what? What? Times what? 0.5, half, right? This means half, yeah? Or power B 0.5, yeah? This is the same thing, okay? Now we have R equals that. And then there are two roots, yeah? Two roots. X1, we use X1, the first root is X1. X1 equals, yeah? Let's write this. Yeah? R, right? So the first root is what? Minus B plus R divided by 2 times A, right? X2 equals what? Minus B minus R divided by 2 times A. And we can return this as a tuple. Return tuple, yeah? What's tuple? X1, X2, yeah? What's tuple? What's tuple? Last question, what's a tuple?
It's immutable.
Immutable list. Look, you can put what's the difference between this? X1, comma X2. These square bracket and X1, X2. What's the difference between these two in Python?
And this is, you can change this to call
Way down. This is mutable list. This is immutable. We call it tuple. So we return two values, X1, X2, representing the two real roots, right? If we don't have a real root, either if A equals 0, it's not a quadratic equation, or this term, this B square minus 4AC is smaller than 0, we don't have a real root, okay? Otherwise, we have two roots.
Yeah.
Got it? Yeah? Why is this useful? Okay, so the last question. What's the time and space complexity for this one? What's the time complexity? Come on. What's the time complexity? Do we need any space? Do we need?
No.
We don't need any space. What? What's the time
Why
complexity?
did you write
Yeah.
an A?
What's the time complexity? We just give a number, we calculate it. Do we need to?
A1.
Because it's not dependent on the scale of the input, right? You give me a million ABC, we still calculate it constant term, right? Okay. Final quiz. This time is the final. 2x squared plus minus 3x plus 5 equals 0. Can you find the root of this? Real root. I say A is 2, B is minus 3, C is 5, right? So what's the root? 2A minus B plus minus B squared minus 4AC, yeah? Okay, we just have to plug in the value, right? A is 2. So this thing is 4. Minus 3. So this thing is 3. B squared.
B squared is
9. 4 times A times C.
40.
40. Okay, so this one does not have any root, right? So it could be something like that, right? Remember? Yeah. Okay. 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 Look at this thing. Look at this thing. Remember what's this? What's this? This is the root, right? This is root, yeah. X1, x2 equal. This is the root, two roots. Symmetric. Remember what's the symmetric? Symmetric axis. Yeah. Yeah. Got it. So this one is the symmetric axis. Remember? Yeah. Okay. Okay. That's it for today. Good job. Bye bye. Bye bye. Bye bye.